Hi, Tiffany Devlin Dry here with my final presentation for my senior project as a student at the University of Florida. Okay, here's a summary of my project. So the motivation is essentially that government affects everybody. Even if you don't participate in an election, somehow the government is going to have some sort of impact on your life, and therefore the leader of the government is definitely going to have a lot of impact. You could also say that they're going to have a lot of impact globally and potentially could affect everybody in the entire world, because America is very strong politically as far as the global perspective. So, more on the motivation is that knowledge is power, and the more knowledge that you have specifically about political candidates, the more power you have over how the election goes. Voter turnout is about 50 to 60% of the eligible voter population in the United States. So even though the government and the president affects everyone, 50 to 60% of us are particularly interested and we care enough to go and vote. So therefore, a way to predict who might be a good candidate is particularly of interest to those of us who plan to vote. Okay, so the problem that this project addresses is that without knowing who may win, it's difficult to strategize. So for example, if I really liked a candidate, but he was actually not a very strong candidate, if I knew that, I might be able to vote for someone else in my party in the primary elections if I really wanted someone in my party to win the overall election. So the solution to not knowing is to utilize machine learning technology to create reliable and custom predictions for the president in 2020. Okay, so here's my progress chart. It's broken up into three main categories. The first one is all the research that I had to do, which is done. I researched different Twitter sentiment analysis ways that you can do that. I researched different machine learning algorithms, different classifiers that I could use. I researched different things that could be used to predict the president. And then the second phase was the implementation phase, which is also done. So I built a custom data set for this project because the data that I wanted to use was not already available. I implemented a part of my program which it connects to Twitter and it gives live Twitter sentiment. So it gives in real time what people think about a particular person or field or whatever. And then I built the classifier and I trained the model, debugged it, all of that. That is all done. I am also basically done with the finalization steps. This final presentation is the last thing that I need to do. And what I've done before this is doing all the testing and debugging and doing my final report. Okay, so here are some of the key references that I used during this project. So the first one just told me that 50 to 60% of us actually go vote and therefore gave me more motivation because people care about this subject. The next one was the keys to the White House. This was important for me because it gave me different things that I could use as possible features in my classifier model that I could use to actually predict the president, things that matter. The next one is how I learned about the naive Bayes algorithm, which I'll get into more in a minute, but that is where I learned it. And then the last one is the one that told me about the Twitter sentiment, and that helped me implement it using Python. Okay, so the first part of my machine learning model is a classifier ensemble. So basically what this means, a classifier is a machine learning model that classifies a data point into a certain class. So for our purposes, it's going to take a certain data point, also known as a candidate, with certain features, and it's going to classify it into either a winner category or a loser category. So the features that it's going to look at are age, whether or not they're an incumbent, so that's a true-false value, their party affiliation, and their home state. So what I did was I researched all of these different features for all of the previous presidential elections and all of the Senate races for 2016, and I put them into my own custom data set. Okay, and then I used this custom data set and I put it through 4 different classifiers. So the ensemble part just means that it's a group of different classifiers, and in this project I used 4. Okay, so the first one that I used was a naive Bayes classifier. Here is Thomas Bayes, and he came up with a theory about probability, which is used to support the naive Bayes classifier. Essentially, how it works is it takes the probability that certain factors are true given a certain class. So, like, for example, the probability that a person is an incumbent and they win, or the probability that they're an incumbent and they lose. So what the naive Bayes classifier does is it takes all the different features and it calculates the probability and it spits out a prediction of either winner or loser based on the probability. The next classifier that I used is a decision tree. This is a classifier which basically builds a binary tree, and it starts at the top and it just answers yes or no to everything. So, like, for example, at the top we might have, are they a Democrat or are they a Republican? So they would go this way if they're a Democrat, that way if they're a Republican. Okay, now that we know that they're a Democrat, are they from a home state in this group, or are they from a home state in that group? Until they got down to a leaf, and at the leaf there is a decision based on the different answers to those questions. Okay, the next classifier was a random forest. So basically what this does is it builds a whole group of different decision trees. It's actually a classifier ensemble in itself. And each decision tree in the forest gets to vote, and whichever class has the most votes is what the prediction is for that particular classifier. So the last one that I used is a quadratic discriminant analysis classifier. And what this does is it basically comes up with some sort of formula, some sort of function. And if it's in below that function, it's in this class. And if it's above that function, it's in a different class. Okay, so what I did is I took all of these different outputs, all of these different predictions from the different classifiers, and I weighted them based on a few different things. So one is I weighted them on how accurate the actual classifier was. So for example, each time that I run my program, I run the naive Bayes classifier 1,000 times just on the training and testing phase. And once it's done that, I can get some sort of calculation on how accurate that classifier is before I run it on the candidate that I want a prediction on. So for example, let's say that the naive Bayes came back with 80% accuracy, and then I go, okay, so tell me how accurate, or tell me what the prediction is for Donald Trump. And then it would say winner or loser for Donald Trump, and then it would have some sort of confidence, like how confident that prediction is. So if you remember with the naive Bayes classifier, it uses probability. So if Donald Trump was going to be a winner with a probability of 51%, it's going to say winner, just like if it were 99% sure. But there's a way to get that number to see how confident that prediction is. So we have 2 things. We have how accurate the actual classifier is, and then we have the accuracy or the confidence of that particular prediction. So what I did is I took both of those numbers and I multiplied them together, the accuracy of the classifier and the confidence in the prediction, and I combined all 4 of those together for each particular classifier. So for example, the naive Bayes, we would have a number like 0.8 multiplied by 0.75, and then we would add that to what we got for the decision tree, what we got for the random forest, what we got for the quadratic discriminant analysis, and in the end we would have a weighted combination. And just for the purposes of ease or simplicity, I made the final score be in between -0.5 and +0.5. So a negative value means that the overall prediction is a no or a loser, and a positive number indicates that the overall prediction is yes or a winner. Okay, more on that during the demo. Okay, so here is how the Twitter data works. So here's some fun examples. We'll just go through these quickly here. So who was the best rapper of the 90s? We have Biggie Smalls, Tupac, or Eazy-E. You can see that Eazy-E won with almost 70% positive tweets. I wanted to know, are people feeling the burn? So we can see here, Bernie Sanders has 34% positive tweets, 19% negative tweets, and the neutral tweets are 46%, which, by the way, I took those out for my model. But this is just to show you how the Twitter stuff works. So I would say yes, people are feeling the burn based on those numbers. Okay, Apple or Microsoft. We have Microsoft has 32% positive tweets, 19% negative tweets, 47% neutral tweets, whereas Apple has 41% positive tweets and only 7% negative tweets and about 50% neutral tweets. So I would say the winner is Apple. Okay, so here is the final model. So we have the data from Twitter, which, by the way, I also do some calculations to make that number between -5 and -0.5 and +0.5. So we have the data from Twitter, and we have the custom data set that goes to the classifier ensemble, and then we have the weighted combination. And then in the end, we're going to have a 2020 presidential winner. So what we're going to have there at the end is we're going to have a number between -1 and +1 for both candidates that we put through the model. And then whichever one has the higher number is considered the winner for that prediction. Okay, so here are some problems and solutions that I ran into. One was how to use the Twitter data, because there's no way I can go back to George Washington and see how people felt on Twitter about George Washington in 17 whatever year he was elected. So what I did was the weighted combination that I just explained. Another question that I had to figure out which classifier I should pick, which algorithm is the best. And I chose to go with an ensemble so that I could use them all. And then the last question that I had was feature importance. So I didn't have to decide, is it most important that the person is an incumbent, or is it most important that they're young or they're old or whatever? I just gave the information to my classifiers, and I let my classifiers figure out the feature importance. Okay, so let's do the demo. I will run it newly. Right now I'm running Donald Trump versus Joe Biden, because Joe Biden is supposed to be a strong Democratic candidate. So here we go. We have individual results for each classifier. So the first one here, we have the naive Bayes classifier. The average accuracy for that classifier after it's run 1,000 times is about 80%. According to that classifier, Donald Trump is expected to be a winner with about a 96% confidence, and Joe Biden is expected to be a loser with about 95% confidence. So the Donald Trump naive Bayes score is 0.09678, and then Joe Biden naive Bayes score is about the same except negative, because we thought that he was going to be a loser based on that classifier. So we have similar things with all the classifiers. The decision tree, by the way, is always going to have 100% confidence, because it's just a yes or no when it goes through the tree. There's no probability calculated or anything like that. So that one is always going to say it's 100% confident. So here we have all of the scores for Donald Trump, and in the end they get calculated together. They get added together right here. And here is his overall score for the classifier ensemble. So this is 0.13439. And then Joe Biden, it's a negative number because the overall prediction is that he's going to be a loser. The reason for that, by the way, is because sometimes both candidates come out to be winners or both candidates turn out to be losers. But in order to be able to compare them to one another, which is really what an election is, we have to have some sort of number attached to it, right? So that way, if we get an election where both candidates are really horrible, aka they should both be losers, then we can figure out some way to tell them apart. Okay, so here is the Twitter information. So the Twitter information, and remember this is live Twitter information, so it's going to change every single time that I run the program because tweets are always coming in about Donald Trump or whoever, right? So here we have 44% positive tweets and 55% negative tweets for Donald Trump. Joe Biden, we have 66% positive tweets and 33% negative tweets. So Donald Trump Twitter score, according to Twitter, he would be a loser because he has more negative tweets than he has positive. And then Joe Biden, people like Joe Biden on Twitter more than they like Donald Trump. You can see that by the numbers. And then when we put them together, we see that Joe Biden is just barely going to be a winner if he's put up against Donald Trump. The reason why it's so close is because historically an incumbent has a much higher likelihood of being reelected. So Donald Trump, for this model, his classifier score was a lot higher than Joe Biden. But on Twitter, people like Joe Biden a lot more than they like Donald Trump. So that is why, in the end, these scores are so close. Okay, so let's just do another one really quickly here. We will change this to Bernie Sanders. And then in the data, we have home state for Bernie Sanders is Vermont, which is represented by the number 48, and he is 77 years old. So we will save that. And we will run this again. Okay, so here we go. We're getting actually pretty similar numbers to Joe Biden. They're very similar historically. They're only a year different from each other. They're both part of the Democratic Party, and their home states are different, but that isn't a very highly weighted feature. So here we go. Okay, so the overall accuracy of the classifiers this time is 74%. We have the overall score for Donald Trump is 0.275 in some, and then we have Bernie Sanders is about the same number except negative. And then we have the Twitter information. Oh, a bunch of positive tweets just must have come up on Donald Trump. So he has a much higher Twitter score this time. Again, this is live information, so it's always going to be changing. So here we have the final score for Donald Trump is 0.73 and Bernie Sanders is 0.15. And it looks like Joe Biden is a much stronger candidate against Donald Trump than Bernie Sanders will be. Okay, well that is all I have, and I guess we will see really how accurate this predictor is when the election happens. Thank you very much for watching, and that's all I have. Thank you.